Welcome to our channel. In this session, we will discuss the stages of a program. So consider any program. The program have mainly two stages. One is compilation. Second one is execution. Compilation and execution. Coming to one by one. What is compilation? The process of checking the program. The process of checking the program whether the program is constructed according to the rules of the language. Simply, compilation stage, the syntaxes of each and every statement is checked. For example, C language have one type of syntax, C++ another type, Java has another type. At the compilation stage, we are checking the program, whether the program is constructed by following the rules of the programming language or not. It is called compilation process. Suppose if the compilation process is successful, assume if the compilation process is successful, consider C and C++ programs. Consider C and C++ programs generate objective code. If you are written a program in either C or C++, after completion of compilation, the output is an objective code. But coming to Java programs, what is the output? After compilation, the output is the bytecode. The output is bytecode. Okay. Once that compilation stage is successful, next we are moving to execution stage. So what is the meaning of execution? The meaning is simply the process of running the compiled code. That is running the objectives code and bytecode. The process of running the compiled code and check whether the result is generated or not. And checking the required result is generated or not is execution process. Now, C and C++, what happened? Whatever the objective code that is generated after the compilation, the objective code is converted into executable code. The objective code is converted into executable code and then generate the result. Coming to Java, whatever the bytecode that is generated after the compilation, the bytecode is loaded on JVM. The bytecode is loaded on JVM for execution. For execution, clear? These are the two stages of compilation, two stages of a program. Two stages of a program. Suppose either C or C++ program. Assume this is the source code. Assume this is the source code. What is the first step? Compilation. After compilation, for compilation, we are using C or C++ compilers. Yes or no? C or C++ compilers. And once the compilation is completed, it produce. Assume my program name is sample.c or sample.cpp. It produce sample.obj. Sample.obj. This is objective code. This is the objective code. Now, this objective code is moved to execution. Internally, at the time of moving to the execution, what happened? Loading and linking is happened. Anyway, we discussed in C, loading and linking, loading the header files, loading the supporting header files, everything, and linking that files, everything is happened. After that, sample.exe, the executable file is generated. This is the executable code. This happened in C language. For example, coming to Java, assume Java program is sample.java. Sample.java. This is the source code for what is the first step? Compilation. For the compilation, we are using Java compiler. After that, what is the next stage? The next stage is execution. It generates sample dot class. This dot class file is called bytecode. Now, at the time of execution, the bytecode is loaded into JVM. The bytecode is loaded into JVM. You got the point? This is the way how the stages are compiled in C, C++, and Java. Now, one question is, what is the difference between object-to code and bytecode? So C, C++ generates object-to code, but why Java generates bytecode? Remember, object-to code means the compiled code generated from C and C++. Object-to code. Bytecode means the compiled code generated from Java. That is called bytecode. So, in object-to code, while object-to code generation process, that is, in the process of generating object-to code, operating system is also participated. Directly object to C compiler directly generates the object code? No. So during object to code generation process, operating system is also involved. Because of that reason, whatever the object to code that is generated, that is platform dependent. Here platform is operating system. But while bytecode generation, operating system is not participated. So because of this, Java is platform independent. Because of this, whatever the bytecode, that bytecode is platform independent. Suppose I will show you. Assume this is some C or C++. For example, assume this one is C or C++. Here we are writing some C program. You are writing some C program. This is C or C++ compiler. If you want to, the compilers are installed in the operating system. So, during generation, assume this is OS. OS is termed as a platform. This is the mission. So immediately operating system, in the sense operating system is installed in a mission. So C++ or C compilers, the object to code is generated with the help of OS. Internally, OS is dependent on the mission. Internally, OS is dependent on the mission. For example, coming to this one, here if you are writing a Java program, now here you are writing one Java program. Java program moves to Java compiler. The Java compiler. This entire thing is the JDK software. The entire red box is the JDK software. Anyway, JDK software is installed in the system. For Java compiler, it does not depends on the operating system. It does not depends on the operating system. Immediately it generates the bytecode. It generates the bytecode. The bytecode is loaded into the JVM. That is the reason. At the time of bytecode generation, the compiler does not interact with the OS. So Java is a platform, bytecode is platform independent. These are the two stages of a program. Thank you.